Hello, junior physicists. This is Mayo Tutors here with you another video. This is the part 2 of the energy and momentum series. Today we'll be talking about question 28. Compare yourself sprinting at 7.0 meters per second with a 63-gram bullet traveling at 150 meters per second. This is essentially a communication question that basically describes the components of momentum and energy and which one's redeemed being more dangerous through a component known as pressure that we'll be covering in this video. All right, to start, which has a larger momentum? So let's break down these two objects and compare the two. So first we have the bullet, and we also have the person, right? Okay, let's first do the bullet. We have the mass of the bullet being 0.063 kilograms. We have the mass of the person, which we will approximate to 75 kilograms. We have the velocities of the two, 150 meters per second and 7 meters per second. We've got to make sure that we put the vector on top of velocity because it is a vector, the arrow, I mean. We have momentum, which is also a vector, mass multiplied by its velocity. So when we are evaluating for the bullet, we see that we have 0.063 kilograms multiplied by 150 meters per second. So we evaluate this to being 9.4 kilograms multiplied by meters per second. Perfect. Then we also have the momentum of the person, of it being 75 kilograms multiplied by 7.0 meters per second. Perfect. Oh, forget the arrows. We also have this evaluating to 5.2 times 10 to the power of 2 kilograms per meter square, or meters per second. Right? Perfect. So we have here that the person represents more momentum than the bullet. Okay, part B. Which one has more energy? We are talking about kinetic energy, which is described by the famous half mv squared. We'll do it for the bullet. We have the EK, kinetic energy, half 0.063 kilograms multiplied by 150 meters per second square, right? We evaluate this to being 7.1 times 10 to the power of 2 joules. Same goes for the person. EK equals half mv squared. EK equals half. We have the mass of the person multiplying by its velocity, and that evaluates to 1.8 times 10 to the power of 3 joules. Perfect. So when we compare the two quantities, we also see that the person, again, has the higher kinetic energy. So when it comes to the last question, part C, which is more dangerous, how do we quantify this? And how do we explain this? So the way to know which of the two is more dangerous, when looking at energy and momentum, we see that the person is much greater in its quantities. But which one's more dangerous? We presume it to being the bullet, because the bullet has such a small area with a great force that is distributed on the person, which makes it more dangerous. So how do we quantify that? The way we quantify this is using the pressure formula. We see that pressure equals the force divided by its area. And that's how we determine that the bullet might be more dangerous than the person. Let's use a presuming example. So let's say for the bullet, the force is 10 newtons. Okay? The area, let's say 0.01 meters square. Let's say for the person, the force is 10 newtons, but the area is, yeah, sure, we do 1 meter squared. This is just for demonstration purposes. This information is not accurate, of course. So when we plug in these numbers, 10 divided by 0.01 or 10 divided by 1, the pressure for the bullet will be much greater than the pressure of the person. So that's why the bullet is more dangerous. More dangerous. A better explanation, this is pretty vague. A better explanation would be that since there's more pressure towards a certain area, let's say the target, the person, the bullet would be would apply much more pressure than the person. Therefore, the bullet would be much more dangerous. And that's it for this video. Thank you for watching.